Hello and welcome to the Superposition Guys podcast. My name is Yuval, and my guest today is Jean-Francois Bobier, partner and director at the Boston Consulting Group. Jean-Francois and I talk about a wide range of subjects, including HPC integration, venture capital investment advice, enterprise projects in quantum computing and quantum security, and much more. We hope you enjoyed this episode. Hello, Jean-Francois, and thank you for joining me today.
Hello, Yuval. Thank you for having me. I love your podcast, so I'm happy to be part of it.
Thank you very much. So who are you and what do you do?
So I'm Jean-Francois Bobier. So I'm a partner and director at BCG, which is a strategy and management consulting company. We created a deep tech research center 4 years ago, and I took a charge of quantum computing with my colleague Matt Languenet, and I've been at BCG now for 20 years.
And you cover, I think, you cover a lot of topics. I think you cover the metaverse as well, but at Quantum, you cover both security and computing. Is that correct?
Yeah, correct. Those are the two, let's say, big opportunities that we've been working on. I would love to investigate a little bit about more what we could do with sensing, which I think is actually a short-term opportunity. But so we prepare a publication on that topic for next year.
Perfect. So what have you learned over the last 6 months, whether in computing or in security? What do you know today that you didn't know in the middle of the year, perhaps?
So last week was Q2B, which is the largest conference and on quantum computing. I had the chance to meet you in person there. I think that I came out of the conference very energized about the prospects of quantum computing. What I learned is that there are so many companies going after the hard problems of quantum computing, and I could actually see roadmaps from Google, Amazon, IonQ, Continuum, and many others, and get some more confidence in the fact that we do have a shot at quantum advantage in 25, 26, which is, I think, would be great news and a great acceleration for the quantum computing industry. So last week for me was a good confirmation for me that we are on the right track and we are making the progress that we need. And there are actual milestones, technical milestones behind it that these companies have built and they are executing on, and that give us a lot more confidence, I think.
If I were CTO of a large company, I'm getting bombarded from all directions about things that I should be doing. Quantum is one of them. And in quantum, if I had to choose one, whether I invest in quantum computing or I invest in quantum security, what would you advise me to do?
I must say we have a French president, Mr. Macron, who like to say you should never make a choice. Actually, you should do both. And I would probably say you should do both, especially if you're a large company, meaning that you have the means, the capabilities to actually take more than one topic. Quantum communications and more importantly, post-quantum cryptography is going to be an important topic. It will be mandated by regulations, standard bodies like NIST, probably as early as 2032 or around that time. And with probably a due date for the final migration, probably around 2035. And that don't give a lot on runway for large companies, actually. We estimate that they will probably need, it took them for Y2K, it will probably take them a decade to transition from the established standards to the new PQC standards. Just because there are so many things in there and so many things that have been hard-coded for so long time, we have to keep in mind that RSA and Diffie-Hellman, have been around for 4 decades. So they are very entrenched in the landscape, certificates, and so on. So it will take a long while I would start thinking about, at least with the new projects and application, I would start making them compliant with PQC and crypto agility. So meaning that I would also prepare for a future where maybe the new protocols are not sure, and maybe if I need to change them, I can change them easy. So that would be one thing. And obviously, and you're part of the industry, so you will probably know that answer very well. I would say that if you're in an impacted industry, so for example, financial services, pharmaceutical, materials, I would definitely advise to prepare for quantum advantage, which we believe will happen around 25, 26, and which means that a lot of people will be suddenly interested, and there will be competition for talent and scarce resources. So it's better to get prepared now, I think.
And by the way, speaking of these large companies, is it the same person that handles both the computing and the security side, or are there two different executives?
Actually, it's even worse than that. There are many executives involved, and that's probably the difficulty of quantum computing program and roadmaps in large companies. For example, if you are in a bank and the benefit of quantum computing will lie somewhere, for example, in option pricing, right? You will need to have the people on the business side of option pricing, so the traders, the people involved in, I don't know, fixed income or derivatives, to be strongly involved. If it's just the IT department, it won't be enough. If it's just some research R&D team, it won't be enough. So it has to be a joint effort between multiple departments. That's the benefit, the beauty of the technology, that is transversal, but also it will require the collaboration from everyone involved. So obviously, the main buyer will probably be the IT department, especially in banks where they have, large IT budgets in the billions of dollars, so they can afford quantum computing. But it will require collaboration from others. Cybersecurity is in the purview of IT most of the time, I would say. So that would remain in the same department.
You mentioned that the cybersecurity transformation for quantum would take at least a decade.
Correct.
How long would it take for the computing side? So I'm excited about quantum. I invite BCG to help me figure out a strategy. I pull together a team. How long before I know what I'm really doing?
So that's a very important question, and I think that there will be at least two or three phases. First of all, obviously, there will be a work around, the use cases, what they are, what is feasible, and that actually you can do now, and you can have a sense of what are the use cases that are relevant for you that could come first. Then you need to work on those use cases with your data, with your specific context, and that could take a lot of time. The nice thing about quantum computing is that many algorithms are actually published, which is nice. So you don't get started from nothing. And also there are many open source initiatives. By the way, I support Unitary Fund, so BCG has been funding Unitary Fund, and I believe open source is really an important part of the solution. But anyway, you will build on the shoulder of giants. So you will take the algorithms devised by others, and you will build on these algorithms to your specific context, your specific problems. And that will take a lot of time and iterations to get right with your, data process and everything. Once that get right, and we could take years actually to get to a good level of satisfaction and usefulness, then you will need to put in production. So you will need to integrate within your in your IT, right? So for example, if you there is a use case in automotive around getting the perfect sequence of cars in a factory. It's a NP-hard combinatorial problem. There are systems that already do that today. So you will need to unplug them where they do this optimization, plug the quantum algorithm instead, then plug it back to the production system and do it at the high speed. So, for example, if it's a continuous process, the quantum computer will need to give answers continuously, for example. So that will be more production challenge. So that's why in total it will take many years. We believe.
One viewpoint that I heard at the Q2B is that there's no such thing as a quantum software product company, at least today. And the reason is that no one is truly selling the product. They're selling their experts to help you integrate, to help you develop the algorithm. And same is true about hardware. If I make a quantum computer, you probably cannot use it as is. You need a lot of help in putting that together. Would you agree with that viewpoint?
Yes or no? I think that if you to inform me on how I can predict how quantum computing will evolve, I always try to go back in time and make a comparison with the early computing efforts in the 50s, 60s. And one thing that you could already note at that time is that the companies were actually providing systems. So systems that would combine software and hardware, because at the time the chips were very limited, the RAM was very limited, the storage was very limited, not dissimilar to the situation where we are today. And it was optimized at the bit level. For example, if you take Apollo 11 computer, I think not a single bit was unused. They used everything they could get out of a computer, they did. So if you take that analogy and you apply it to quantum, my prediction, but I might be wrong, but that the first systems that will deliver value to customers will be software plus hardware integrated systems, and probably the hardware company that tries to combine that and try to get the most out of the hardware, for example, in the forms of accelerated libraries or dedicated software that does certain tasks. I think they will deliver early value to their customers. And I don't believe that in the short term, a clean and nice separation between hardware and software will work out. We'll just have to admit that we'll have too many limitations with the hardware. Long term, obviously, we'll get to the same situation where we are with classical computing, where we have a clear stack, and I use a Intel processor now, but I can use an AMD processor tomorrow. The same software will run, no problem, right? But here we are not at that point yet. So I would say that I believe the system approach will work better, and that's why we have companies like Continuum who basically merged. They are a full stack company, or IBM, they have their own software capabilities, and so I could give a lot of names like that.
Do you see the quantum computers being part of the high performance computing data center, or do you see them still separate on the cloud with whoever provider, Bracket, Azure, and so on?
So there are a lot of discussions. So there is a first discussion around technical feasibility, and then there's a question about acceptability from regulatory / business standpoint. So let's look at the two things here. So the first is around, is it feasible to put quantum computing on the cloud? The answer is obviously yes, and it's because, as you know, quantum computing is a slow input, slow output type of computing, right? You give actually very limited data to the quantum computer. It operates in a large space 2 to the power of n, but the inputs you give to the machine are actually, you don't give that much input. It's not like Netflix. It's not 4K video or whatever. It's not like that, and it's definitely not something that requires low latency. However, So let me just give a little caveat on that one. Is that, as you know, there are a lot of algorithms, the variational ones, that do quantum computing, then quickly go to classical and then back to quantum, and then they basically iterate. So that's why they are called variational. And on that one, you might want to optimize as much as you can the latency of this algorithm. Even though, honestly, you could argue that the preparation time of the states, the readout time of the states, and so on, are still high compared to the networking, right? But it's still an argument you might hear. So from a purely technical standpoint, I would say that you could actually live on the cloud. I'm not actually that concerned. But now, if you look at now the companies working in HPC settings, and I know a lot of my clients. So, for example, tech banking, for example, right? They have actually regulations that force them in terms of where their data centers are located. They have to comply to very specific regulations, so data cannot go outside of certain jurisdictions and stuff like that. So they can't put, in other words, they can't put their computation where they want. So it's very likely, for example, I can see banks buying their own quantum computer for at least that reason, and probably for another reason, which is around security, avoiding that data could get read or whatever. I talked also to pharmaceutical companies, same answer. They don't want to take a risk that their patented drugs can get out somewhere, and there's a high, at least in some people I talk to, let's say, preference towards having the computer in-house. So you will see that data privacy will probably play an important role. But you could say that for very highly computing intensive variational algorithms, maybe you could make a case that even from a technical standpoint, it could make sense to have a computer. So in my opinion, you will have a world where it will be hybrid. A lot of computing will be procured via the cloud. And I think probably 70 to 90%, and the rest will be on premise.
BCG operates in multiple continents, and I know you collaborate a lot with Matt in your Boston office. You published recently a paper discussing the differences between US and Europe in terms of quantum computing, in terms of private investments, in terms of the government work, and so on. I'm curious about the end users. Do you see a big difference between the requirements and the adoption rate of enterprises in the US relative to Europe?
So that's yeah. So thank you for mentioning this report. So basically, on the supply side, what we say, and for example, we look at the private investments, and that is public data. That if you take North America, including Canada, the North America captures close to 80% of the investments in quantum computing, and that's private investments. So not counting what Microsoft, Google, IBM, or Amazon are doing. So that comes on top, right? If you compare that to Europe, it's more 10 to 15%. So clearly, on the supplier side, there's a clear advantage for North America. Clearly, just because of what I just said. So obviously, but now if you look at the users, I would say that it's a more balanced discussion. If you look at the early adopters of quantum technologies, a lot of them are actually in Europe. You look at the Airbus, Total, EDF, BMW, Volkswagen. I think there's this perception in Europe, and that's true in deep tech in general, that Europe has kind of missed the digital wave and has a chance to catch up with quantum and deep tech. So we will see more interest in Europe, but out of that, angst or worry. Now, if you take what the large US leaders are doing, it's still very awesome. I mean, if you take just banking, the two leaders in quantum computing are clearly JP Morgan and Goldman Sachs by far, and what they are doing is just excellent. Just to give two names where I believe that what they do is world class in quantum computing. And the proximity, obviously, with the suppliers will tremendously help, right? But I think it's a fairer fight on the user side than on the supplier side.
And I do see that in Europe there are quite a few national programs. I mean, Germany is now spending a lot of money building a quantum computer. Netherlands opened a quantum house. UK, Finland, and so on. I think in your report you mentioned that perhaps many of these programs are not truly coordinated. The quantum flagship doesn't have maybe as much synchronization between them. Is that the case? Did I read your report correctly?
Yeah. So we didn't write it implicitly, but it's clear that, I mean, let's say there's room for better coordination for sure. I think nobody will deny it. When we did the interviews, that was pretty clear. So we could do better. The question is, I still believe that some dose of competition, of fair competition between states, I don't think it's a bad thing actually. So as long as it helps move the needle and lift all the boats, I would say it's not necessarily a problem. Could we coordinate better? Probably yes, but is it necessarily a bad thing? I don't think so. If you take the US, for example, even in the US, you've got some federal government funding, obviously, but you've got a lot of state funding. For example, if you take Illinois, they have their own funding. And if you take over states, you will find that they also compete for funding and to get quantum computing companies in their state. So I would say that it's not that different. We could do definitely better, but I don't think it's a major problem.
We're getting close to the end of our conversations, but I did want to ask you about investors. I know that BCG does a fair bit of work with investors. And just between us, right? What are you advising investors today to invest in? Do you think that in 2023 we will see a lot of consolidation of smaller companies into bigger ones? What's your investment thesis in quantum these days?
Well, yeah, that's a billion-dollar question. I think first of all, we have to recognize that there are many different computing approaches that are competing. And I don't think we can give a winner yet on, superconducting versus photonics versus trap ions versus neutral atoms versus spin qubits. So I don't think it's too early to say, hey, technology X is gonna work. So what I recommend to investors is actually to have some kind of balanced strategy where they don't bet everything on one technology, because it might be and actually chances are that it won't be the right one, right? Just because there are 5 technologies, so if you pick one out of 5, the chance that you are good is actually not very high, right? Even though you could say that obviously there are a lot of scientific evidence pointing that way or that way, but I think it's very difficult to predict, right? So I recommend to have a balanced strategy, at least invest in 2 or 3 different technologies, in promising companies in these technologies. So that's one. Second thing, regarding consolidation, I think is bound to happen. I mean, look at where the IT market is today, which is and it's a $5 trillion market. And look at where the quantum computing market is today. There are just too many companies to support what we believe will be $100 billion market per year, in 10 to 20 years. So that's too many players to share that. So consolidation will happen. The question is, when will it happen? I think we will probably see, and there already been in consolidations. As you know, Supertech has been acquired by Colquanta. Pascal bought Q and Co, and there have been moves similar to that, and there will be more going forward. The question will be more, when the big techs, like the IBMs, Amazons, or Microsoft, or Google will make their move, and when they will decide that some startup as the technology that they believe is important, and we'll start to see more consolidation at that point. So overall, I think it's still a good moment to invest in quantum computing. I think, but you need to have a balanced strategy, or you need to be super sure and have an information that I don't have on what technology is going to work out in the end, because that is super difficult to predict.
So, Jean-Francois, we are here at the dinner question. So, if you could have dinner with any one of the quantum greats, dead or alive, who would that person be?
Yeah. So now, if you give me that, clearly, I mean, probably like 90% of people answer that, but I would probably say Feynman, just because I admire the guy. He was the youngest group leader in Los Alamos. He was actually in charge of computing the size of the atom bomb, and this is how actually he realized that it was difficult to compute classically these things. The guy was funny. I could see his lecture, so also you can have fun with the guy talking. And also, I liked his approach, to think in analogies and trying to make sense of the equations, because it's super hard, right, to have even though he would always say that people who say they understand quantum, they just don't. But he was good at trying to get some good understanding, of what's going on, and give some explanations. And I mean, and I think he would be proud to see where the industry is today. And also, I think the first use case that will be relevant will be probably around his original vision of quantum computing. That is, simulating nature. I think it's going to be the killer app at the beginning.
And of the European greats?
European, great. That's a good question. I would probably say Niels Bohr, but that's a lot to ask, right? But the guy was just, he did the foundational stuff, right?
How can people get in touch with you to learn more about your work?
So LinkedIn works very well. My email address is super easy to guess, but you can click on any publication to reach me. There's a link to contact me, and obviously quantum computing conferences.
Excellent. So, Jean-Francois, thank you so much for joining me today.
Thank you so much for your questions.